If you have looked at Stoic 4 tutorial before this, maybe you want to pause the video and try solving it yourself, and then we compare notes. Uh, Please try solving these problems. The more you do, the easier it gets. Stoichiometry is not easy, but with practice it becomes easy. Then again, I have an organic compound that contains carbon, hydrogen, oxygen. It's being burnt and you produce CO2 and H2O. And first part of the question is, what is empirical formula? So the compound of this organic compound, C, X moles, hydrogen, Y moles, oxygen, Z moles, is being burnt in presence of oxygen. You produce X moles of CO2 and you produce half as much Y moles of H2O. Then again, all the carbon goes into CO2s and H's are going into H2Os. So I go after CO2 and I try to bring back to life amount of carbon. Molar mass of CO2 was 44. It's still 44. Atomic mass is 12.0. Now, if I look at my own number in this question, 2.79, I'm trying to find out how many X grams of carbon I produce. X happens to be, when you cross multiply, 2.79 times 12 divided by 44 is equal to 0.761 grams of carbon. So I'm boxing it. Then again, in IB you have partial credits, so try to answer as many parts as you can. The second part of this problem is, how much hydrogen do I have? So I go after H2O. Knowing myself, I make mistake. In every one H2O, I have twice as much hydrogen. Molar mass of H2O, 18. 2 hydrogen is 2 times 1, which is 2. And then let's go after the information in the question. 1.71 grams of hydrogen, H2O, contains Y grams of hydrogen. And when you cross multiply, Y happens to be 0.190 grams of hydrogen. Then we have to find out how much oxygen we have. And if you add X and Y and subtract from 1.46, which is the total amount of the organic compound, Z, or amount of oxygen, comes to life. So Z is equal to 1.46, take away 0.761, added to 0.190. So Z happens to be 0.509 grams of oxygen. I know many of you don't like to write the units. Please do so you don't make mistake. But 75% of us at this stage divide by decimal, and we are happy, we get numbers, and we are under the impression we solved it properly. You have to convert the grams into moles. So for carbon, 0.761 grams divided by 12.0 grams per mole. Hydrogen, same conversion, 0.190 divided by its atomic mass, grams per mole. And oxygen, you have 0.509 grams divided by 16 grams per mole. When you do this, the fraction here is 0.0634. Here you get the same number, 0.190, and here you will get 0.032. The smallest of all three numbers is 0.032, so let's divide it by that and come to simplest whole number, hopefully. 0.032. Let me just clear this and do it one more time, slightly nicer than this. So this is 0.0634, 0.190, and this was 0.032. Divide all of them by 0.032, 0.032, 0.032. Once you do that, you have 2 carbons. You will have 6 hydrogens and you will have 1 oxygen. So empirical formula is C2H6O. Now let's go to other slide and see how we are going to solve the molecular formula for this. Now, if the relative molar mass is 93, what is the molecular formula? So you have C2H6O, and you're trying to find out what's the ratio that you're multiplying it through. Now, this ratio is simply molar mass divided by empirical mass. Since the question has relative, I'm going to squeeze it in. Relative molar mass. And I'm going to divide it by relative atomic mass, so it just becomes a number. Now, the word relative simply says there is no unit. Otherwise, you would have units of grams per mole. So this is 93. Now, the question is, what is relative atomic mass? You have 2 carbons, 6 hydrogen, 1 oxygen. So it's 2 times 12 plus 6 times 1 plus 1 times 16, which is about 46.1. This division is approximately 2. So your final molecular formula is C2H6O multiplied by 2. So you have C4H12O2 as your molecular formula. I'm done with the series of empirical formula and molecular formula. The next few tutorials I'm going to just simply solve basic stoichiometry, mass, mole. See you then.